and today I'm going to take science. Now we will learn about pressure in this section. So today's our chapter is atmospheric pressure. Now before starting the chapter, I will give you some example. Now remember the activities like brushing the teeth, then switching the TV on, changing the channels, and writing on the board or writing on the notebook. These all activities consist of force. That means we need force to apply for these activities. So you know that you already learned that by using the force we can change the direction of the moving object, or by applying the force the stationary object can be set in the motion, or by applying the force the moving object can be stopped, directions can be changed, and also by applying the force we can change the shape of the object. So by application of force we do so many things, so that I will write it here. Now by the application of force we can start the motion of stationary object. So force is required to start the motion of stationary object. Secondly, we can stop the moving object. Thirdly, we can change the direction of the moving object. So, to change the direction, also by applying the force we can change the speed of the moving object. So to change the speed we have to apply the force. And also the last thing, we can change the shape by applying the force. So to change the shape of the object, now you must be thinking that we are studying about atmospheric pressure and why I am talking about force. Now in this particular section, in this particular chapter, we will see the relationship between the force and the pressure. Now for that purpose, here I will give you some example. Now suppose you have a wooden box. In that you will take mud and you will put a brick, means brick that is used in construction work, that you will put it horizontally, that I will draw you. So suppose this is the wooden box full of mud, and in this mud you are putting a brick horizontally, means like this. Now remove the brick and measure the length, means measure the deepness of that shape of the mud. Now this is the depth which brick has covered inside the mud. So this is your first case. Now in the second case, what you will do, same brick you will keep in the mud vertically. That means you will not place it horizontally, you will place it vertically, means like this, and again measure the deepness covered by the brick inside the mud. What you will see? You will see that when we put the brick vertically, the deepness or distance covered by the brick is longer, means larger area is covered in this case. So what it shows, means with the same pressure or with the same force we are keeping the brick inside the mud, but in the second case the deepness is larger. Why this happened? Because here actually in the first case the area of brick in the contact with the mud was larger, hence the deepness was lower, and in the second case the area in the contact with the mud is smaller but the distance covered by the brick is longer, means depth is longer. So that means there is some quantity which is proportional, means which is related to force as well as area. So this quantity is called as pressure. Means in the first case area is longer, though I am applying the same pressure, means I am keeping the brick with the same pressure in both the cases, still in the first case deepness is lower, in the second case deepness is larger, because in the first case area is longer, hence deepness is lesser. In the second case area is shorter, means I am talking about area which is in contact with the mud. So area is smaller, that's why the effect of force on that area, means effect of force on that area is showing, means we have the means deeper effect in this case, means our length inside the mud is more. So here we defined a new quantity known as pressure. So before that, formula for pressure is force upon area. Now when a force is applied to an object, the effect produced on that object depends upon area of the surface on which force is applied. Means the force acts according to the area of the object, and here there is the quantity known as pressure which is giving the relationship between force and area. So we will define the pressure as force applied on unit area of a substance is known as the pressure. So we will write it here. Pressure is defined as force applied per unit area. Means suppose I am saying that I am applying 1 Newton or suppose 2 Newton of force on 1 square meter of area, that means your pressure will be 2 upon 1, that is 2, and unit we will calculate here. Now the unit of force is Newton and unit of area is meter square. So if we represent pressure by P, then its SI unit becomes Newton per meter square or Newton per square meter. So this is the unit. Now here in this particular part we will solve some examples later on which are not from your textbook, but it is for your understanding. Now suppose here to clarify the concept of pressure in detail, I am giving you one example. Take one nail. Definitely nail is pointed at one surface and at other surface it is circular having flat. Then if you try to hammer that nail in opposite way, means you are pointing the flat circular area towards the wall, then what will happen? Means I am telling you, suppose this is the wall and you are trying to hammer nail in this way, means you are pointing the circular area towards the wall and trying to hit it. What will happen? Definitely the nail will not go inside, since here this circular area is larger. So my applied force will get distributed around all the points of that circular part. So the action of hammering will not take place here. Then means action of going nail inside the wall will not take place here. Now in the second case, here we are taking the same wall, but now here I am hammering the nail in this way. Now here you can see the area at that point is very smaller, means the area on which force is doing action is very smaller. So that's why here area is smaller, force is of same kind, then definitely the pressure will increase, and because of that your nail will go inside the wall. So that's why nails are pointed, and we have many examples like knives, then examples of using pointed objects that we have at home. Those all have the sharp edges or pointed areas for cutting or piercing purposes. You have seen the sewing machines and all also. So they have very smaller area. So by chance if we are in the contact with them accidentally, we can have a cut and all because of their sharp edges. With little application of pressure, they can get into our skin. So this is the pressure which is acting on a area. Now to show it mathematically, suppose this circular area is 1 centimeter square. Definitely here I am taking it as directly 1 centimeter square, but in the examples it may have happened that means you have given the radius. Accordingly, this is the circular section. So area of a circle is pi r square. So accordingly you have to substitute the value of pi and radius, and along that you will get the area. So here that area I am taking it directly. So circular area of the nail is 1 centimeter square, and suppose I am applying force of 1 Newton, then the pressure will be 1 upon 1. It will be 1 Newton per centimeter square. Here I am taking area in the form of centimeter, so this will be centimeter square. Now if suppose similar case here happening, now you can see here the area which is in contact with wall is just point area. So it may have the area of 0.001 millimeter square, or it can be less than that. Suppose for our convenience I am taking this area as 0.01 millimeter square, and same force I am applying 1 Newton. So pressure will be 1 upon 0.01, and also this I am taking in the form of millimeter. So I want to convert it into centimeter in order to compare these two quantities so that our unit will be same. So here we have 10 raised to minus 4. So you can see our pressure will become 100 into 10 raised to 4. That means it will be, you can see, you can compare these two pressures. It is lakhs of times greater than this pressure here. So that's why in the second case our nail goes easily inside the wall because of increased pressure. Now suppose this area having zero area, means we can neglect the area, then you can see pressure increases infinite times. So this is the case where there is relationship between force and area which is given in the order of pressure. So pressure is very important quantity in order to calculate our day-to-day work, and also in order to use proper instruments for proper use. Now here we will do one more thing. Now here I have explained you the example of pressure exerted by solids. Now whether the same concept is applicable for liquids or gases, that we will see. Means whether liquids or gases apply the pressure, that we will see here. Now, in the first case, if you remember the example of brick putting inside the mud was the example. So brick was inserting the pressure on that mud. Now here we will perform an experiment to show that liquids or gases can apply the pressure. Now we will take one bottle, empty bottle, plastic bottle. You can take 1 liter Bisleri bottle and all. Now here you have this bottle. Now at the bottom of the bottle you will make one opening and you can put rubber pipe inside, and on that particular rubber pipe you will fit one balloon here. Now before, means at the starting of the experiment, your bottle was empty. Now you can fill it with water, and after some time what you will see, your balloon will start blowing because the water inside the bottle will get inside the balloon. Now this example shows us that the water exerts pressure on the walls of the bottle, and because of this pressure the water inside your bottle is going in the balloon. So this experiment shows us that liquids also exert pressures on the containers, on the walls of the containers in which they are filled. So this was the experiment to show us that liquids also exert pressure. Now what about gases? Now here this is simple experiment that you can also perform with another bottle. Take a bottle, plastic bottle or a Bisleri bottle. In that you have, means you will take that empty bottle. Not what you will do. Now press the bottle so that the surface of the bottle will go in. Now fit the cork of the bottle. What you will see, the bottle is shrinked. Now without touching the surface, just hold it from the bottle and slowly release the cork of the bottle. You will see that because of air entering inside the bottle will become initially how is what, means it will become perfect. Now its shape will regain. Now this shows us that before, by pressing the bottle, air came outside. Now we are releasing the cork, that means we are allowing air to enter the bottle. So now this air is inserting or exerting pressure on the walls of the bottle. Because of that, bottle is taking its original shape. So this is one example. You can perform similar activity which is given in your textbook, that you will perform it with can. Now gases also exert pressure. For this we have very simple example. See, we will take different shapes balloon. We can take heart shaped balloon or round shaped balloon, oval shaped balloon or longer balloon. In all the cases, suppose we are blowing same amount of air inside, still also the balloon takes their own shapes. Means they are not taking similar shapes to each other. They are taking their own shape, means heart shape, oval shape or long bottle type shape. Because air or liquids, means liquids and airs or gases are the fluids, means they can flow. So that's why all the fluids exert similar pressure or equal pressure in all the directions of the container in which they are filled. So this experiment proves us that liquids and gases, that means all the fluids which can flow, exerts equal pressure in equal direction in that container which they are filled. Now here, to show you, I will take the another experiment here. Suppose now we have another similar two bottles here. or we can take container to container here. Now you will join these two containers by making holes in them, and you will put one rubber pipe here, and on that pipe you will apply one clamp so that you can open or close the flow of the fluid, or you can control the flow of the fluid from these two containers. Now in the first case you will close the clamp and you will pour some water here. Second container is empty here. Now what you will do, after filling the first container, you will open the clamp and you will allow the liquid to flow in the second container. Now after some time, what you will see, now the liquid is flowing in the second container. So after some time you will see that liquid flows till that point where all the levels in the two containers become equal. So after some time the flow of liquid will stop since both the levels are equal here. So this experiment shows us that fluids flow from a region of higher pressure to a region of lower pressure. That means in the first container initially I had water which was having mass and a volume. Now because of this mass and volume, it was exerting pressure on the walls of that container. So because of that pressure, the fluids start flowing from first container to second container, and when the pressure in the both the containers become equal, fluid stopped flowing. So this is the experiment from which we can write the conclusion that fluids flows from a point or region of higher pressure to a point or region of lower pressure. Now best example of this is flow of ocean airs. As you know, when the pressure at the sea level increases, means I am talking about air pressure, air start flowing from sea level towards the city or the whatever area is nearby that sea. So this is the example that air also flows from point of higher pressure to a lower pressure. Now what about the pressure that we feel or other objects around us feel due to atmosphere? Now in the next part we will learn about atmospheric pressure. Yes, our atmosphere is also applying some pressure. I will explain you how. Now as you know, on the earth, means earth is the only planet having the shielding of atmosphere. Now in this atmosphere we have different gases like oxygen, nitrogen, carbon dioxide and dust particle, also water vapor. Now all these particles definitely have some kind of mass and some kind of volume. So because of this mass and volume, they have some density, and these particles are exerting pressure on us as well as all the objects around us. So this pressure which is applied by atmosphere is known as atmospheric pressure here. Now you have to think, since our atmosphere is applying some pressure, so why we can't feel that? Means it is like we are carrying 100 of tons of weight on our head, but we can't feel it. How is it possible? Because in our body there is blood flowing. That blood is also have the similar pressure as that of the atmospheric pressure. So both the pressure are equal and opposite to each other. So because of that, they cancel each other and we don't feel any kind of pressure on ourselves. But most of the phenomenon and most of the objects or experiment in our day-to-day life shows us that there is atmospheric pressure acting on the object. Just I mentioned in the example of empty bottle, and secondly in this particular case, in this experiment, definitely there is atmospheric pressure acting on it. Means there are two kinds of pressure. One pressure due to water itself and second pressure is atmospheric pressure. Now when water pressure and atmospheric pressure both becomes equal, the flow of water stops here. That means the level among the two containers become equal. So this example shows us that there is a atmospheric pressure here. Now you can also see the example of filling the ink from the ink bottle in the ink container, means ink pad. What is acting inside? Means you have that ink pad, you press the bulb of that and you fill it in the bottle, then you release the pressure or release the bulb, then ink came inside that dropper. So what is going on here? Initially you have a dropper, the balloon was at original shape, means there was air inside. When you press it, air inside the dropper comes out, so that area inside that balloon is empty here. Now when you dip inside the ink bottle, the pressure, I will show you here. Suppose I have this ink bottle, there is ink inside. Now when I'm dipping the dropper inside, what happens? Now there is no air inside the dropper, so air tries to move inside the dropper, but the mouth of the dropper is inside the ink, so along with ink, air goes inside the dropper and we fill the dropper. And when we press the dropper to fill that ink in the pen, the ink goes inside the pen. So this is also example of atmospheric pressure. If there is no atmospheric pressure, we will not able to fill the dropper here. Now there are many examples also. You have seen rubber sucker. What rubber sucker did? Actually this is also used if your sink is blocked. You press that sucker and because of pressure applied by the sucker, the whatever garbage is inside the, means whatever clog inside that sink, it goes down. So rubber sucker that stick tightly on the glass surface are available in the market. Observe them carefully and you will find that when you press the rubber sucker on the table or on the sink, what happens? Air between the table and sucker blows away. So there is no air, so no atmospheric pressure. So very little surface is in between them, so they get tied to each other since there is no any space because of the air, so no atmospheric pressure. So this is the example of atmospheric pressure again. Now here